So, good afternoon, everyone. My name is Pooja Yadav, and I'm working at Luke as a research scientist. And as you can see, my presentation topic is environmental benefits of reusable food packaging. So, the goal of the study is identify the environmentally sustainable food packaging solution based on new food delivery processes using end of life reuse, recycling, and incineration, and compare the results with conventional food
Sorry,
plastic
sorry,
packaging.
Pooja,
Yeah,
sorry for interruption, but could you put a presentation mode? Yes, thank
yeah,
you, thank you.
yeah, that's perfect. Okay, yes. So, sorry for that. So let's continue. So here we do the LCA analysis of reusable food packaging boxes. These boxes manufactured of polypropylene, and the weight of these boxes are 138 gram. The capacity of box is 1.2 liter, and the purpose is of course food packaging. And normally the service we use for these boxes are takeaway, and these boxes are recyclable and incinerable. So you can see this figure, and this figure is showing the whole life cycle of the reusable box that start from extraction of raw material, and then using polypropylene produced these boxes. And actually these boxes has produced in Sweden, so those are transported to Finland, and then we distribute these boxes in different stores, and from there the customer can use, and then it give back to the store that it could be clean, and then finally it collected after many reuse and use, and the end of life is recycling and incineration with energy recovery. So whole stage is divided in production phase, transportation phase, washing phase, and end of life. So here is some information related to data that we use for LCA analysis, and the data is the core in LCA analysis. So we use two types of data. One is the primary data that we have taken from industry, our industrial partner, and the secondary data that used for this analysis is from Ecoinvent 3.6 database, and also from the literature such as like a production of PP, production of detergents, water, and finish mix electricity. So emission, we also consider incineration. So emission of related to incineration based on the carbon content of the material, that's PP. And the recycling model assume that recycled material will be replaced by the virgin material, and the material losses 20% has considered in the study. So this is the data, primary data that we use for the LCA analysis, and here you can see that the amount of polypropylene and consumption of electricity in the production stages per box, and the transportation and the consumption of electricity, detergent, water in the washing stage, and the end of life in recycling. We have considered mass loss, that's 20%, and energy consumption. And in the incineration end of life, we have considered electricity recovery and heat recovery. So find out the most efficient scenario. We have to propose some scenario using these reusable boxes, and there is a different numbers we propose. There is a, you can see on screen, 10 times. If we use these boxes 10 times and then go for the end of life recycling and the or incineration, and the same boxes if we will use 30 times, and it will go for end of life recycling or incineration. And we have considered maximum potential here 100 times for these boxes. So we did this kind of scenario analysis and try to find out which one would be the best one. So in this slide, you can see the figure that how this box works. So you go to store, buy some food, and just pack this food in this reusable box. You eat it and then give back to the store, and they will clean, and then this box again ready for reuse. So this is the cycle that all that's will follow by these boxes. And here for the LCA study, always LCA study have some limitation. So the system boundary that we have considered in this study is cradle to grave. It means we try to consider everything from extraction of raw material to end of life. And because we are going to compare these results with some other conventional food packaging results, so for the healthy comparison, we use one use of box as a functional unit. We also have done some comparative analysis using reusable box and single box. So you can see here that reusable box have a quite high weight in compared to single use box. And for the comparative analysis, the end of life is used same for the both its incineration and recycling, and the mass loss and everything has considered same. And we also conduct some sensitivity analysis because there is some other parameter that affect in the results. So one is from them is the behavior of consumer, because these reusable box designed to use as much maximum we can use, but there is also possibility that some people use it once, twice, or thrice, or just dump in the dustbin. And what will be the results then, and how it's is it beneficial or not. So we also try to consider those part. And energy always have a very important part in production chain. So we also try to find out if we change in the source of electricity, what will change in the result. So these parameter we have considered for the sensitivity analysis. Some results. So first is the results, that's so the contribution analysis. This means that the whole life cycle of one reusable box, how much it has CO2 emission in production phase, transportation phase, and washing phase, and end of life. So you can see that recycling have a benefit over incineration, and production have a little higher CO2 emission than other stages. Here is the results related to scenario analysis, and you can see the recycling is 10 times, 30 times, or 100 times is have much better result than incineration for same times use reusable box, same box. And for the comparative analysis, if we compare this 10 times, 30 times, and 100 times in compared to single use box, what will be the results using the recycling. So you can see that single use box have much higher than 10 times reusable box, that box used at least 10 times, 30 times, and 100 times. But if this reusable box use less than 8 times, then it's not beneficial, because then the CO2 emission will be higher for the reusable boxes. So 10 times is the at least it's good option to use at least 10 times, or not less than 8 times. And same trend has followed by the end of incineration scenario. So you can also see that single use have higher than reusable box that could be used 10 times, 30 times, and 100 times. That's maximum potential we assumed. And here we have some benefits over single use box. So you can see that incineration have more benefits than recycling. But for sensitivity analysis, so here we compare that if reusable box dump in dustbin after one time, someone has used one time and dump in dustbin, and it will go for incineration, then CO2 emission will be this higher in compared to uh, yes will be higher. And so it is important, at least it should be used 8 times or 10 times, otherwise we will have a no benefit over single use packaging. And here is the result if we change in the source of electricity. So here electricity normally that used in whole study was mixed finish electricity that's come from like biomass, nuclear, hydro, wind, and oil, gas, and some percentage from coal that we have replaced by the 100% hydro. And we see that there is a very minute changes in the results, not so much. And another difference we have noticed in figure 9, that if we have 100 single use box and its end of life is recycling, then it have a CO2 emission quite higher than one reusable box that use 100 times. So these are the differences in the results change. Here are some conclusions that we find out. Reusable packages decreasing CO2 emission, that's obvious. And this depends how many times we can reuse, because at least we have to reuse these reusable boxes a a fixed number. If we will not use that number, maybe it's not beneficial. 100 times reusable box decrease approximately 76% CO2 emission if we consider end of life recycling. And if we consider end of life incineration, this will increase approximately 95%. Overall, recycling is much better end of life option than incineration, but recycling have their own some limitations, so we also have to consider those points. And the energy source is also very important parameter, because depends where these kind of services uh, we are using. For example, if we are using somewhere there the electricity is 100% coal based or quite high percentage, then the results will change. And of course customer behavior have a high influence in the results. Those if you have any question, you are most welcome.
Kiitos Pooja. Thank you. Any questions to Pooja? I can't see any questions in chat, but if you have, you can now also have an oral question.
Thanks a lot, Pooja. Actually, I have one question. So, what do you think? What is most interesting in your work?
My work, I think overall my work is quite interesting to comparing that like okay, in practical life how will be change the CO2 emission and all, and this part I think this was quite interesting to see. So I would say yeah, doing the modeling part is quite interesting for me. Thank you for your question.
Thank you.
Yes, there was very interesting results, lots of them. So if you want to still ask some questions from Pooja, you can write them in chat.
Please.